Every pilot learns one chilling truth early on. Planes don't fall from the sky because their engines stop. They fall because the air stops playing along. And when air quits behaving the way a wing needs it to, you get the most misunderstood killer in aviation: stall and spin. Ever watched an aircraft climb steeply, turn sharply, or pull a wild maneuver and wondered, how close is it to disaster? That fine edge is called the critical angle of attack. It's the razor-thin boundary between lift and a sudden, catastrophic drop. So what's really going on? A wing generates lift by making the air move faster over the top than underneath, creating low pressure above, high pressure below. But the real trick is the angle of attack, the angle between the wing and the oncoming air. Increase it and you get more lift. But if you push it too far, past that critical angle, the smooth airflow shatters. The wing stops making lift, drag shoots up, and suddenly you're dropping. That's a stall. Not an engine failure, not running out of speed, just running out of airflow you can control. But here's where it gets dangerous. Stalls hardly ever happen symmetrically. Usually one wing stalls first, so you get a rolling moment. One wing's still making some lift, the other's dead weight. The plane yaws, rolls, and spirals down. A spin. In a spin, the aircraft corkscrews nose down, losing altitude terrifyingly fast. Modern jets can drop thousands of feet in seconds if you don't recover immediately. Now, the instinct in a stall is to pull up, but that just makes things worse. You have to push forward to reduce that angle of attack. Only then does the wing start flying again. And to break a spin, you use rudder, not aileron. Push the wrong control and you're in even deeper trouble. That's why accidental stalls still catch pilots out, even with advanced computers watching your back. History is full of lessons. Take Air France 447. The pitot tubes iced up, the sensors failed, the autopilot switched off. The pilots pulled back thinking they needed more lift, but all they got was stall warnings as the plane plummeted from 38,000 feet. Or Colgan Air 3407. Where the captain's instincts led him to pull up, straight into a fatal stall. Fighter jets in the early days? They'd push too hard during dogfights, exceed that critical angle, and tumble into flat spins, like a leaf, spinning all the way down. Even in small planes, the danger is real. Most fatal accidents start with a stall during the traffic pattern, usually while turning final. Instinct says, pull back, but that raises the angle of attack. One wing stalls more, the plane flips over, and there's no altitude left to recover, but modern engineering helps. Wing design, stall warning systems, stick shakers, and even angle of attack indicators all buy us precious seconds. Fly-by-wire systems guard the critical angle too, but the physics, they haven't changed. The stall doesn't care about power or speed. It only cares about that angle. That's the terrifying truth. No matter how advanced the airplane, push past the critical angle and the air stops holding you up.